All right, guys, today we're working on something called Noble Gas Configuration. All right, Noble Gas Configuration, also called the shortcut method. Because if you notice with some of the electron configurations that we've been doing, all right, with some of the electron configurations we've been doing, you get really long answers. Okay, so this is a way to take some of the long answers and to make them shorter, so that way you don't have to write as much. Okay, so I'm going to scoot this up here so we can use it as a reference. The first example that we're going to do is iodine. Okay, iodine is sitting down here, atomic number 53, located in the 5th period, P block, and the 5th element over. Okay, again, here's what iodine's electron configuration looks like. Okay, it took me a long time to write out. What you're going to do for this shortcut method, also called noble gas configuration, is we're going to use the noble gases to help kind of compact what we've been doing. Noble gases always finish at a P6. Okay, so 2P6 is neon, 3P6 is argon, 4P6 is krypton. All right, and that's the last one here. So what you're going to do for noble gas configuration is you're going to find the element that you need, which in our case is iodine. You're going to go up a period and then all the way to the right where the noble gases are is this last column here. And you're going to start with that noble gas and you're going to write it in a bracket. So here we're going to write krypton in the bracket. Okay? By writing krypton like this, that's like saying that we have, I'll do a different color. Okay, that's like saying that we're going from 1s2 all the way to 4p6, just assuming that we haven't. Again, you can only do this with noble gases and noble gas before the element. Okay, so krypton, which is 4p6, will go right here. Okay, now we start with the row or the period that iodine is in. Okay, iodine is in the 5th period, so I start at the beginning of the 5th period, just 5s, and then we go from 5s to 4d, and then to 5p, and we said iodine was the 5th one over. Okay, and we know from past videos that s's hold 2 electrons and d's hold 10. Okay, so in the past, the way that I said to double check that you have the right answer is to add all the superscripts together, and it should equal your total number of electrons or the element's atomic number. With noble gas configuration, you can do the same thing. What you're going to do is you're going to start with krypton's atomic number, which krypton has the atomic number of 36. So 36 plus 2 is 38. Plus 10 is 48, okay, or 10 makes it 48, and then plus 5 is 53, which is what we need. So this right here is the noble gas configuration for iodine. Okay, so some more examples that we're going to do together, okay. Is HF, which, when I wrote this down, I forgot to write down the atomic number so I could find it faster. Here we are, 72. Okay, so it has the atomic number of 72, which means it holds 72 electrons. This is in the D block, and remember, D block is 1 off the period. Okay, so 6th period, it's going to make this 5D, 1, 2, because it's the 2nd one over. All right, now instead of starting all the way up here at 1s, okay, I'm going to go up to the 5th period, and I'm going to go all the way to the right where we have xenon. Okay, that's my noble gas. So I'm going to start with xenon. Okay, and just so I can reference later, xenon has 54 for the atomic number. All right, so we write down xenon, and then we start with the period that it's in. Okay. So we're going to start with 6s, because again, that's like saying we went all the way here. So next we have 6s. After 6s is 4f. After 4f is 5d. And our element is in the 5d block. So we can just finish it with 5d2. Then when I go back and fill in the numbers, we know S's have 2 elements. F's can hold 14. If you don't remember that, okay, if you don't remember how many F's can hold, you can count the elements in the F block. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 elements means 14 number. Got it? All right, so when we're double checking to make sure that we are in fact correct, we're going to do 54 plus 2 is 56, plus 14 is 70, plus 2 is 72. That's what the atomic number is. Okay, so there's 72 total, so we know we did right. All right, so the next example that we're going to do is selenium. All right, where is selenium on the periodic table? All right, selenium's right here, the atomic number 34. And it's in the 4th period, P block, and it's 1, 2, 3, 4 over. So 4, P4. Okay, what element do we have before selenium? Or, sorry, not element, what noble gas do we have before selenium? Okay, before selenium, we have argon. Okay, so this is going to be argon right here. Okay, then, and I'm back. All right, so we have argon as the noble gas, that's before selenium, because again, we went up a period and we went all the way to the right. Okay, that's where we found argon. Argon has the atomic number of 18, so we remember that later. Okay, and argon is 3p6, so if I start after 3p, then we hit 4s, 3d, and then we hit the 4p's, and we know it's 4p4. S's hold 2 electrons, and D's hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and D's hold 10. So 18 plus 2 is 20, plus 10 is 30, plus 4 is 34. And that's how we know we did this one right. Okay, so you go ahead, pause the video, and see how far you can get on gold, which is right here. All right, gold is located right here on the periodic table. All right, so it's going to have 79 electrons, and it is located at 5d9. All right, so again, pause the video, find the noble gas configuration. And now I'm going to go ahead and start writing down the answer. So again, pause the video if you haven't already, try it on your own. So here we have gold in the 6th period. We go up and over to the right. We see that xenon is the noble gas before gold. Okay, so xenon. And xenon has the atomic number of 54. All right, and if we start after xenon, which is 5p, then we hit the 6s, then the 4f's, and 5d, which is where gold is located because it's the 9th one over. We remember that s's hold 2, and we talked earlier how f's hold 14. So when we do 54 plus 2, that makes 56, plus 14 is 70, plus 9 is 79, which is how many that we need. So this is what your noble gas configuration for gold should look like. All right, again, you don't have to be an expert in noble gas configuration if it confuses you. You just need to be able to recognize what the element is when you see this, okay? But if you want to do a shortcut method, this is just a way to save you some time. All right, thanks for watching. Have a good day.